Properties of determinants. In the previous section, we have learned how to expand the determinants. In this section, we will study some properties of determinants which simplifies its evaluation by obtaining maximum number of zeros in a row or a column. These properties are true for determinants of any order. However, we shall restrict ourselves up to determinants of order 3 only. Property number 1. The value of the determinant remains unchanged if its rows and columns are interchanged. Property 1 says that the value of the determinant remains unchanged if its rows and columns are interchanged. Verification. Let delta is equal to determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Expanding along first row, then we get delta is equal to A1 into determinant B2, B3, C2, C3 minus A2 into determinant B1, B3, C1, C3 plus A3 into determinant B1, B2, C1, C2, which is equal to A1 into B2, C3 minus B3, C2 minus A2 into B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1. So we get the determinant. Now, by interchanging the rows and columns of delta, then we get the determinant delta 1, which is equal to determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Expanding delta 1 along first column, then we get delta 1 is equal to A1 into determinant B2, C2, B3, C3 minus A2 into determinant B1, C1, B3, C3 plus A3 into determinant B1, C1, B2, C2. This is equal to A1 into B2, C3 minus C2, B3 minus A2 into B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1. Thus we get delta is equal to delta 1. Next one, remark. It follows from the above property that if A is a square matrix, then determinant A is equal to determinant of A transpose, where A transpose is equal to transpose of A. So remark says that from the following property, if A is a square matrix, then it must satisfy the condition determinant of A is equal to determinant of the transpose of A. Note, if Ri is equal to ith row and Ci is equal to ith column, then for interchange of rows and columns, we will symbolically write Ci arrow mark Ri. Now let us verify the above property by an example. Example, verify property 1 for delta is equal to determinant 2 minus 3, 5, 6, 0, 4, 1, 5, minus 7. Solution. Here delta is equal to determinant 2 minus 3, 5, 6, 0, 4, 1, 5, minus 7. Expanding the determinant along first row. Then we get delta is equal to 2 into determinant 0, 4, 5, minus 7. Minus of minus 3 into determinant 6, 4, 1, minus 7 plus 5 into determinant 6, 0, 1, 5. This is equal to 2 into 0 minus 20 plus 3 into minus 42 minus 4 plus 5 into 30 minus 0. This is equal to minus 40 minus 138 plus 150, which is equal to minus 28. Now by interchanging rows and columns, then we get delta 1 is equal to determinant 2, 6, 1 minus 3, 0, 5, 5, 4 minus 7, expanding along first column. So it is equal to 2 into determinant 0, 5, 4 minus 7, minus of minus 3 into determinant 6, 1, 4 minus 7, plus 5 into determinant 6, 1, 0, 5. This is equal to 2 into 0 minus 20 plus 3 into minus 42 minus 4 plus 5 into 30 minus 0. This is equal to minus 40 minus 138 plus 150, which is equal to minus 28. So clearly delta is equal to delta 1. Hence property 1 is verified.